Ça va? Yeah. I'm good at French. My name is Marcin Krzyzanowski, and I'm here today to talk to you about the amazing world of Swift tools to parse and manipulate the Swift source code. So to get started, I want to tell you a little bit about what I'm gonna tell you today. So first, I will define the problem. Then I will introduce you to the SwiftSyntax library. After that, I will build the simple command line tool that will manipulate the source code and solve the problem. And after that, just briefly, I will show you what you can do with the index source DB library. So first, this is the problem. This is the problem I created. Problem is that sometimes the source layout in our code is suboptimal. Basically, it's a mess. The solution is to reorder pieces and align to desired structure. For the purpose of this presentation, I'll work on this handcrafted source code. It's a class named conference with a bunch of methods that are randomly laid through the file. The mess is easier to see if we cut off the body and look only at the interface of the class conference. You may notice that the public initializer is at the very end of the file, while private initializer is somewhere in the middle. Internal and public methods are mixed up. This is pretty much how I would like to have this file structure. So I put the initializers at the beginning, then public functions, methods, then internal and private at the very end. My task is to transform source from the left side to the source code on the right side. For a second, let me discuss what are my options to get from point A to B. So I can move the lines by hand, Control-C, Control-V, copy-paste. But I have to do that every time, and if I work with a team, I have to do that every time, right? If we do not agree on the protocol. I can use the IDE or editor helpers, not Xcode, obviously. But if I use any other IDE, there is a plugin that will let me do this transformation. I can use one of the tools that are already on the market, on the GitHub, like Swift Format by Nick, Swift Format by Google, and Swift Writer. They are worth to check out. Or I can write my own tool because this is what I like to do. For the purpose of this presentation, I will write this tool by my own. Why do I need to build that tool? I need a brain. I need to spend some time, a computer, programming language, that is Swift in that case, and some library that will help me.
You have brain.
I have brain. Since I have brain, and I also have an internet, so I have superpowers, right? With the superpower of my brain and the internet, I'm gonna use these non-randomly selected tools. But first, I will just mention tools that I didn't pick for this task. First is ANTLR. I don't know, maybe any of you is familiar with that tool? Raise your hand if you. 5 people. Great, because it's more popular in the Java world. NTLR is very old, very good parser generator. You create the grammar, like language grammar file, and this tool will generate library based on this grammar that is specified, that is built specifically for this grammar, for this language. So then you can use that as a library. I'm not going to use that. I tried. Yeah, there's the NTLR Swift playground. I tried. It's too slow, basically. Like, I don't know what is the reason. I guess it's Swift. But it's too slow. You can't work with that. The other one is a tool I didn't choose is PCRL, regular expressions. Regular expressions are great, if you know Perl. Great. However, it's not very the tool to analyze the source code. Like, you can use that, but it will be inefficient. Can I back somehow? Yeah, what I choose is Swift, of course, SwiftSyntax, which is the library. It's a wrapper around the lib syntax library that is part of the Swift project itself. And IndexStoreDB. IndexStoreDB is a source code indexing library. I will tell you more about this. I presume a majority of the audience already is familiar with the Swift programming language, so I will skip that part, and I will move to SwiftSyntax. SwiftSyntax is an Apple project, binding to the C library, and this library is part of the Swift toolchain. So whenever you download Xcode or download the Swift toolchain, this library is available. It is responsible for lexing the source code and parsing. Lexing is an operation that will change the stream of text into tokens, like words. And parsing will give some meaning to the series of tokens. The output of SwiftSyntax is abstract syntax tree. And this is the data structure that we will work today. Abstract syntax tree is a tree. Question about tree is the question from the interview process, so I'm sure everyone knows how to work with tree, how to invert tree, right? So I'm going to skip that. And the thing is, abstract syntax tree preserve full source, meaning the source code can be written out from the AST, preserving the very same characters. A syntax node represents a tree of nodes with tokens and leaves. Each node has accessors to its children and allows efficient iteration over children. To iterate over the tree in this library, I will deal with a visitor design pattern. It's a pattern that lets me visit the nodes of my interest. It's also chosen because it allows to lazy process the tree. To give you an example, I created a visitor. I created a visitor that is interested in processing the initializer declaration only, which is init. Right? For that, I implemented just a single method, visit initializer declaration node. At the end, I can decide whether a visitor should iterate over its children or not. In my example, I just skip it. So I can save some CPU cycles because I was only interested in this one node. Another use of the visitor pattern in Swift syntax are rewriters. Syntax rewriter let me iterate over the syntax tree and decide whether I want to keep the visited node or replace it with a different node, which, as a result, I will mutate the abstract syntax tree. Here, it's a nonsense example, but just one-liner. I replace initializer with the class declaration. It doesn't make sense. It won't compile, but you can write code like this. And with this tool, you can do whatever you want. Okay, so the plan for this, for the tool, I'm going to write here in 10 minutes, because this is how much time I have left. First, I want to find all the functions or methods. Next, I will sort the functions. And I will sort it by access level and by kind. After that, I will rewrite syntax tree, replacing existing functions with the functions in the right order. At the end, I reconstruct the source code and output to the standard output. So the first, search all the declarations. By implementing indexer, I will get all the methods that I'm interested in, and visitor will iterate over the tree, and whenever I find a function, I remember that function in the array functions. So it's just append to the array. So we have an indexer. Then the functions has to be sorted, and this is the main logic. I sort by access level, and below I sort by, let me see, by the kind, which is first init, the init, and functions at the end. You can see I use some small visitors just to process the node that I'm interested. So here, LHS visitor, and I walk through this tree. I just read some parts of the declaration I use. Specifically, I get information about access level. Having that in place, I implement a rewriter that will swap functions with the ones from the sorted array. The number of functions didn't change, hence I iterate over the syntax tree and return functions one by one with my order. Nothing else changed. Body of the function is intact. It's just printed out in a different order. And the processor, where I use all that information together. So first, I parse the source. Then I gather information about the file, which is the indexer. Then I run the rewriter, will modify the syntax tree, and output the syntax tree as a string. Then I need some boilerplate to run this command line tool, which is not that much. Just get a parameter of the file and run the code. It looks like this. This is the tool that we just built. On the left, you see the output. On the right, how it is executed. So it's just a command line. Everything is ordered just as was planned.
Avez-moi.
Yeah. However, you may have a feeling that what just happened was this. That's not really true. Actually, I show you full source for the simple source code formatter. It has some limitations for the presentation purposes. So there's a homework. The source code is published on GitHub, on my account. You will find it as a Krzyzanowski reorder. And if you want to play with that, just grab the source code and try to sort properties as well. See if you can get an extension in a scope, like extension of the class. Also, try to sort the static function and property. I think it's a very interesting homework. One more thing. You remember this indexing, right? Yeah. So it's happened all the time. And what's going on underneath? It's indexing. It's indexing the source code. And we have a tool to read that index. The tool, it's a library lib index in a Swift, but the Swift framework is index store DB. We can reach to that index and query for symbols, for example. First, how to build the index. Well, it happens automatically. It came to Swift from Clang, and it is in Clang since Xcode 7, I think. So it's part of the building. There is a feature, index while build. And when we build this, the Swift project, the index is created automatically. This is the example from Swift Packet Manager, enable index store, that is enabled by default. We'll create the path, debug index store, where the store is physically stored. But we can index just a single file as well. Swift compiler has this options where I point it to the path, index store path, index file, and the file I want to index. And it will create the index wherever I want. Now, if I have a index in place, I can use the index store DB to query that index. First two lines are like library, index store library. You have to point to the library from your Swift toolchain. It's a bit tedious, but yeah, that's how the initializer looks like. Then there's a path to the store, and index.pull for unit changes and weight is basically read, initialize the database. Starting from that point, I can ask for any symbol that was indexed. Here, index.canonical occurrences of name, symbol name, in my case it's a conference, will return me all the places with the file and line number and the position where this symbol occurs in this project. So I can use that. I can use that in my favor to improve a little bit the tool I just built. The improvement is I don't have to specify a file for the conference. I just say, OK, find me where the conference class is located and reorder that. Right? And this is what I've done. It gives exactly the same output as before. This is the code from the previous slide. And you know what?
Avec-moi.
Yeah. There's one missing tool I won't discuss, but it's important to know, and I'm sure most of you heard of that. If not, by the tool, you saw this Bazel, that source kit crashed, right? Yeah, so the source kit is a real thing, and you can use that. You can use that outside the Xcode. The source kit by itself is quite hard to use. It's like a daemon that communicates with the protocol. However, there is a source kitten project, open source project. It's great, and Deliver gives you the Swift API to deal with the source kit. Thanks to that, you can feel like an Xcode and deal with the project just like Xcode does. So you can resolve the types based on the cursor position and many, many more. So I think we just build a tool, right? And I hope that I will get some pull requests from you, like today. There's some links if you're interested in processing the source code. There's some links with the interesting reading or performances. First by Nick Lookwood. It was last year on the French Git. He was talking about how to build compiler in Swift. Now, Nick is the author of Swift format. This is great. But this is not the Apple Swift formatter. This is what Nick wrote, and it's I recommend to use it. Adding index while building to LLVM. Great talk from the LLVM guys, how they implemented the indexing while building, how the structure of the database is built. Creating refactoring transformations for Swift, that will help you if you happen to build Xcode extension. Because there's a chance that you will use some of this knowledge to build an Xcode extension to work with the source code. And the reorder is the tool I just built. The full source code is on GitHub. You can check out, and I'm waiting for you pull request. That's everything. Thank you very much.
Thank you. Thank you, Marcin.
Thank you. All right.
Please join us.
Okay.
It's nice to see that we can do that, especially with Swift. It seems that with other IDE, like, I don't know, Visual Code, people are doing that all the time.
Swift Studio, yeah, I've heard.
And now it's actually available to us. And it's not just being fun, but also it seems that doing that kind of tooling will also improve your knowledge of Swift and make you a better developer, right?
Definitely. It allows to understand what's going on and why the Xcode crashes, or why it's a struggle to work with. Because on the surface, everything looks like, come on, right? It should work, but it's not always works. There are edges that are hard to handle, basically. And this is software, and software always break.
Yeah. I mean, so what you mean is not always Xcode default. It's like the underlying tooling.
Yeah, it's still the same company, but yeah, it's not always the one team.
Yes.
And to be able to do a real tool that you would use that would be really useful, is it hard to handle? Like if we start from what you showed us today?
No, we can write a Swift formatter in a week, I believe.
Okay, the audience was asking if you want to create a prettifier, how would you do that?
The same, just use the classes that we created, the indexer and the rewriter specifically, and just put the logic in that class. The Google Swift formatter uses the very same tool, SwiftSyntax.
Okay.
This is built on top of this. And it's fast now. It was slower at the beginning, but they rewrote it, and the current version, because it's based on the C library, of course, it's fast.
Okay.
So you can put that in your build chain and not be...
Yes, definitely. Yeah, you can put it in an Xcode, like a building phase.
Build phase, yeah.
Or pre-commit hook.
And did you measure, like, is it going to slow down a lot?
No, I didn't. I don't have measurements, but the guy from JP Simar,
yes, who wrote
SourceKitten guy.
SourceKit. No, SourceKitten. SourceKitten.
Yes.
Yeah.
And Jazzy.
He was here like 3 years ago.
Yeah. He did some benchmarking because they tried to use
he likes benchmarking.
First version that was slow, but the new version is fast enough, so they probably can use it now.
And there's also one really practical question is, do you keep, while converting to AST, do you keep the comments?
Yes, everything. It's called trivia. It's part of the syntax node.
Okay, so you can imagine adding some
definitely.
stuff on the. I guess that was the idea, like adding some stuff in the
Oh, yeah,
comments and use it to.
You can build your own tool to add the documentation, for
or
example.
Generate some architecture.
Yes, because everything is there. White spaces. It's called trivia, but there are tokens and trivia. Tokens are the meaningful part of the string, and trivia is everything else. But it's still there.
Okay.
How long does it take to get all the knowledge? I guess, I mean, Swift Studio was a great bench, like a great playground in a way to get to know all that stuff. How long did it take to get a grasp on the tooling?
Oh, I guess two days, and
really,
yeah, really. Like there are a lot of talks that you can just watch. They take you half an hour each. And there are a lot of talks from LLVM community that are more closer to that than from the iOS community.
And they're accessible?
Yes, the LLVM meetups are recorded, as far as I know.
No, but accessible in terms of understanding. Like it's not. If I see an LLVM talk, I'm going to say, okay, will it be understandable?
Yeah, unfortunately, it's mostly about C++. However, if you know one language, you just get the idea.
Okay.
You don't have to read the API. So yeah.
Speaking about LLVM, one thing we forget, I guess, in the community here in Paris, is that there is a great LLVM meetup still going on from years ago, and yeah, it still takes place, and it's a good
way to learn.
A good way to learn
deeper things. Okay.
Shall we? There is a question from Antoine, which asks, when is Swift Studio going to be released?
Oh, it's released on my machine.
Yes. It works on your machine.
It works on my machine, and I'm waiting for the Catalina release, so to update to 64 bits, of course.
Okay, and will I get that on my iPad OS?
No. If you use the car side.
All right.
No, that's a problem. Actually, we can talk about it. Only Apple can build a tool that will run on the iPad, because there's no way to run the debugger on the iPad with our privileges. And as some of you may know, that Swift Playground, it's a debugger, like LLDB, basically, and Apple can do that. We cannot do that. So most of that efforts will just fail.
Okay, and is it just a technical issue, or
no? It's not a technical issue. It's a more like
Also
what you can do and not.
Yeah, yes, nothing.
Technically, yeah, it is possible. But
awesome. Yeah. Thank you very much.
Thank you.
Thank you. Thank you, Marcin. Yeah, thank you very much.
Thank you.